Hello everyone, I'm Xiao Gang. Okay, in this lesson we'll mainly write this health component because now that we've calculated the damage value, we definitely need to respond to changes in health, right? So we'll extract a separate health component to handle these issues. Let's go to the component section. Go to the component section. And now we want to create a new component for this health value. This health component is quite complex because it involves linking with death, so it's relatively more complicated. Let's call it Seogang RPG. Okay, after creating it, let's refresh the project. Okay. After refreshing the project, let's go to our health component. First of all, we still need to include this header file. This header file just needs to include our component base. Then remember to include the reflection file. Then we set a program once here. Include the parameter. Okay. Then we include the header file in the source file. Okay. Then we first write the emotional quotient citizens here. These are all emotional quotient citizens. We'll ignore them. Then we first declare a delegate here. A delegate means when this death event occurs, a dynamic delegate, because we need to expose it to blueprint. That is, which player dies. It's a death event. Then we prepare a dynamic delegate here. 4 parameters now. That is which values have changed. Let's align it like this. Okay. Good. Should write it like this. Good. Okay, so it's roughly like this. Then we prepare an enum here. Because this death is quite complex, let's write the enum suggestion up to here for now. This enum means current death start and death completion, because it may involve animation, and also involve other settlements. So let's put the enumeration here for now. Now let's write this component. Let's first make it inherit from our this county base. We should inherit from component base. Okay. If we inherit from component base here, we might need our modern base to inherit from game framework component. Find our base, make it inherit from this. For this, we might need to include the header file. Let's check where it is located. We need it here. It is inside components. Also inside components. It's the same. Clicked wrong. It should be here. Let's look at this component. It also inherits from ActorComponent. However, it actually provides you with many methods. You can see there are some templates here that allow you to conveniently judge these authorities or precise things, so we can have it inherit from this to reduce the amount of code we need to develop repeatedly. Then after we have such a component, we start writing its constructor. Let's write this constructor here for now. Don't instantiate it yet. Then we write a method here to help us quickly find these components. Then this is a static method. It can directly pass in an actor and then look for it. If we can get this component through reflection, we can get the health component. Then here we can initialize RDAC system, that is pass in an ASC, because we have some delegates that need to be initialized since you have initialization. then you definitely need the initialization, right? So this is what this means. Then we will provide a few more methods so that it can be used in Blueprint to get our health value, for example, and then maximum health value, and then this maximum mana value, and then the normalized mana value, maximum mana value. This is essentially like getting the ASC and then going around it, like triple save to get attributes. Then on this side, we need to get his current death state. If this state enum hasn't been defined yet, we can just define it now. Let's put it at the very bottom. This state needs to be synchronized over the network. Because this is more complex, we'll ignore this death for now. So that is a state like this. Okay, then how do we determine whether it is dead or not dead? Actually, we mainly just need to check this enum. Next, let's continue writing further. Here, we prepare 3 methods. As for these 3 methods, we might not be able to write them yet. Let's write this is our when we start dying, when we finish dying, some functions to execute. This is equivalent to going out of bounds. That is falling to death, or death by going out of bounds, a function that will be triggered. Okay, then next we activate this delegate page. These delegates, a total of 6, are all relatively simple. Health change, max health change, then mana change, then max mana change, and start, and complete. Okay, so next, let's write the methods. This part is public because we need to do the binding externally, because it needs to be exposed to Blueprint for binding. Okay, and this part is where we do the unregistration when unregistering. This is an overridden method. We might use it later. And this clear game tag, mainly when we die, we need to clear the tag. Okay, next are these methods. These methods, don't think they look too many or too complicated. It is actually about binding to our method on the ASC. That is to say, we first need to bind ourselves to our attribute set and then call the thing we have bound in the blueprint. That's roughly the logic. Okay, good. These methods are also done. Then we finally write a synchronization method because this thing is synchronized over the network. So we synchronize it here. Okay, now let's go through these methods one by one. Implement it. Let's go through it again from the beginning, like this. Because this thing, there's no way to explain it to everyone in a scattered way. Because this code, it's just like this. It's just like this. Because if you explain it too scattered, there's no way to teach it. Okay, alright. So this is a constructor. Then first, we disable all its tick functions. After disabling them, we need to make it default. It can support network synchronization, and at the same time our ASN component. We set it to empty. Okay, our ASC component seems not to have been set yet. So we have some variables that need to be obtained during the initialization process. So here, we place it because many of our attributes need to be accessed through these 2 groups. So that's how it is. And here we need to access this thing. We will initialize the properties of this, only perform an initialization for the ones inside. Next, let's look upward. And because we only need to synchronize 1 variable, so in this place, we only need to synchronize this DS. And here, since it involves networking, so we just need to include this input key. Okay, and by the way, I will also include the other input keys, the ones used before, like this. Okay. Then, actually, Lyra has some tags here. Let's paste some of the tags here, because they might be used later, so we'll paste them over. There's not much to say about these tags. They're just tags, and since we need to use tags again, we'll include this header file here. Okay, now that you've declared it, you'll definitely need to implement it. Let's put the implementation here. Okay. These are just some tags. There is nothing much to say about this. Okay, after finishing this part, let's continue writing below. When we initialize our ability system, we have a lot of work to do. Because this involves network persistence, we can only give you a simple guarantee. We cannot guarantee this order 100%. First, for this component, this method must belong to the owner. That is to say, What it means is, in other words, its owner must exist. That the meaning here is, next we will check whether our AC main component exists. If it exists, then it is a fatal error, because our initialization only initializes once. When we initialize, it must not exist. So the logic here is like this. You should be able to get this point. That is to say, before our initialization, it must not be a null pointer. The logic here means this, okay? It is a null pointer. Then we cannot assign the past value to it. After the assignment is done, it cannot be a null pointer, because if this is the case, it means your timing is wrong. So this needs to be handled. Then after it is no longer a null pointer, we should be able to get this attribute side. Then this attribute side, it also cannot be an empty child. If an empty child appears, that proves your timing is wrong again. Okay. Then when we have all of these on the attribute side, we just bind these methods to it. These methods are the ones we wrote on the attribute side, and we did not directly expose them to Blueprint. We let them transfer from C++ to one layer. Transfer to our health component for processing this thing. So here we just bind it directly to these 5 methods of this class. And then here is a piece of code. This part is just to say, reset this value. It is possible that this part needs to read a table, but we haven't implemented table reading here. So this part essentially sets this attribute, the health value, to be the same as the maximum health value. Normally, at this point, you would read the save file or read a table. Modifying it with level coefficients is fine. Then at this point, we need to call these 2 delegates. So these 2 delegates are different from this delegate. This is the delegate inside our component. This is the delegate inside our attribute set. These 2 delegates, it's a dynamic delegate. It is written like this. This way our blueprint can bind to it. The prompt here, it means our health and our maximum health. These have all undergone such a change. That's what it means. Okay, then actually we should also include the mana here. It should also be possible. Let's not include it. Never mind it. Normally, another one should be written here. Fill in the missing part here. You can fill this in yourself. I won't touch it. Then here, we need to clear this tag. Clear this tag. What is this tag for? What does clearing the tag do? We created its implementation. This tag is actually when we die. We might want some skills to be unavailable. So we set this tag, the statue tag, into it. So clearing it means removing this tag, because with this tag, when we implement the skill's primary fire, we know we are currently. So the tag at this location is set up like this, because our component, this tag is all processed on the ASC. Okay, let's continue with the next part. Okay, then let's take a look at what work needs to be done during our unregistration. Actually, during unregistration, we first need to clear this tag. That is, remove it, and then remove all our attribute sets. Complete, and at the same time, set these pointers of ours to it as well. Set phone length set. Looks like we missed something here again, but we won't worry about it. This is a minor detail. Ignore it. Okay, then let's take a look at how our get files and get machines are written. Let's create them first. This creation is a bit slow, but this is still relatively simple. Let's write down these methods. Actually, forget health. It can be done directly through our attribute set. Just call get health directly. The same goes for make health. Yes, make health. And at the same time, let's get mana. Get max mana. Normally, mana should have been separated out. But this is just a demonstration. It's fine. And here, we might need to do a division right here. That is, divide the current value by the maximum value. That's the idea. Basically, this way, we are good. Then, Let's write this dot death and this finish death. The function of this may only become apparent later. Let's write it for now. Okay, we'll leave this empty for now, because the code inside is a bit complicated. The code for it to self-destruct is a bit complicated. Okay, if we start dying, let's first check if the current state is not equal to this. Load death. If it is not equal, proves that you are dying. If you are equal, proves that you are not dead yet. Then you can start dying. Then we modify this state. After the modification is complete, we add our tag at dying type to it. After adding it, we let it broadcast this. Broadcast this death start event, because this is another. So here we let it broadcast, then force an update. Then, when we have completed the death, we must be in this start death state. Only in this state can we complete the death. We complete the death. Regarding this state of completing death, then we give this tag to it. The death has been completed, this tag. Then, similarly, we broadcast the death completion event. Then we force an update. Okay. Alright, basically. Let's write this reverse strategy as well. This is an override method. This is an override method. An override method means it might be the engine that calls it from somewhere else. So here we just cancel our ASC. That's it. Then we call this method of its parent class. Now let's focus on this. Here we provide several methods to bind, right? Let's create it. Okay. We haven't created this method either. Let's create it. This 08 should write a implementation. Just write it like this. Let's check. Maybe it's commented wrong again, because this is hard to comment on. Let's check. It seems this one doesn't need to be assembled. This one doesn't need to be assembled. Yes, only RPC ones need to be assembled. Okay, good. Let's go back to our part. When we handle health value changes, we actually just need to activate a broadcast once. Similarly, when the maximum health value changes, it's the same. But if we encounter this handout of health, then it's quite special. In this case, we might have a lot of work to do. When we might need to calculate the score, this must be done on the server. Okay, so let's leave this part aside for now. We'll write it later. Let's leave this part blank for now. Leave it blank for now. We'll write it later, because if you write it now, you won't remember it. Because in this lesson, we're writing very, very redundant code. Okay. Nick, when we synchronize the death state, what should we do? First of all, we get our current death state. Then we take our current old state and save it as this state, right? And this is the new state. This is the old state. So I write it this way. It is to perform a validation, because if this old state thing is greater than the new state, it proves that you have a serious error, because your synchronization is incorrect. That is to say, you have encountered some issues. So when our old state, it is this. When not dead, this state, right, but then its new state is equal to the state of death start. So we are at, on the side where we receive the sync, we start death. And if our new state is the state of death complete, then we need to start death. At the same time, we also need to complete death. If neither is the case, then it proves there is a problem with the code here. Just ignore it, okay? Then if our current old state is this death start state, the death start state, then our new state is the normal complete death state. This proves it is a very correct transition. We don't need to worry about it. We will handle it here. If it is not, then it proves there is a problem, meaning your transition is problematic. Then After we finish processing, these two states should both be the same. This part is essentially a death judgment check. Okay, basically, we have written the life component for you. Let's build it. It should be fine. Okay, let's see what errors it reports. This part should be the game 4. It might require such a construct. So we may need to make a unified modification here. Okay. Then when modifying here, we may need to check our other components. They might also need to be modified because it seems we compiled it earlier. Okay, right here. There is no default constructor. We might need to handle this here. Right here, since our flake has changed, let's compile it again. Okay, compilation passed. So in the same way, we also need to instantiate this component on our character. And instantiate it. Come with me to instantiate this. The intensity of this chapter in our course should be very high intensity. Everyone, try your best to keep up. Just bear with it. It's about 10 hours or so. After you follow through the entire workflow, when you go on to learn any GIS tutorial, you should find it very easy. Okay, so the tendency declaration here, after the declaration is completed, we should add a method here. We can just add it in this position. This is HealthComponent. Okay. Alright, so now that we have created it, we need to instantiate it in the hook function. As for this health component, we put it under the combo component. It requires network synchronization. This means we need to include the header file. This one requires network synchronization. Then here we are. We can see that this component in the constructor, it should have been given this network synchronization. Just in case, let's enable it anyway. Yes. But actually, you don't need to write this here. It should be fine. Then on our character class, we later write two methods. If we want to do this on the character class, these two methods, we write them on underplay. Because we only died on the component, but when we die, we should not play it. Or if it's some special effects, then we still need to go back to the character class to make a relay. So when we start dying, we go and turn off these movement settings and these collision settings. Just turn them all off. Then when the death is complete, we let it distort. But we need to distort on the next frame, not so quickly. Don't distort too quickly, because that can easily cause problems. We often emphasize the staggered shape. We have these two functions put together and explained here for everyone. Okay, so let's take a look at this side. How should we write it? We create it. Then this disable movement end. That correlation is relatively simple. You just need to call similar methods. First, get our controller. Just ignore the input. In the controller, then get our capsule component. This capsule component definitely exists because this is our character accumulation. Just ignore the church body. Then also get a moment component. Then immediately stop moving. Then disable this moment. Right. Then here we might need to include this, the church body and such. Let me check. We should need to include these two game classes. Okay, so this disable moment is done. It just disables some functions. It's that simple. Then when we finish, then in the next frame. How do we do this? Let's first adjust the blueprint because we need things starting with K2 are usually blueprint methods. The engine source code usually likes to write it this way. Then let's first have the blueprint finish all the visual effects. After it's done, we let it underneath to distort. Then when underneath distorting, this is not needed. This doesn't need to be written. Then on the server side, we can only distort on the server. We set the health value on the server to 0 and F. And at the same time, we have a health component here. We cancel this thing here. And then we can hide our actor in the game at the same time. Okay. So we should be almost done writing on the C++ side. Let's compile it. This lesson is a bit long. Okay, there should be no issues with the compilation now. Alright, let's stop here for now.